Welcome to Brain Vision.
The Schrödinger equation is given by negative h bar squared over 2m times the second derivative of psi with respect to x, and in this case is equal to the energy times psi, because u is equal to 0. So we'll go ahead and get the first derivative, and then we'll get the second derivative. So d psi with respect to x, the first derivative, is negative k times a sine of kx, because the first derivative of a cosine is a negative sign. And similarly, the first derivative of a sine is a cosine. So here we have k times b times cosine of kx. All right, so now we'll get the second derivative, and that is the derivative of the first derivative. So here we'll just write d dx of d psi dx. And we can write the second derivative out here as equaling this. So now we have a second k that comes out times k a, and the derivative of sine is cosine. So we have cosine kx, and the derivative of cosine is negative sine. So now we have a negative k that comes out times k b and sine kx. And this can be simplified as negative k squared a cosine kx minus k squared b sine kx. And we can simplify one more time by factoring out negative k squared from both of these terms. So we have negative k squared times a cosine kx plus b sine kx. Now, if you notice, this is really just the original function, wave function, times negative k squared. So we'll just write this for short as negative k squared times psi. Now we can substitute this back into the Schrödinger equation. We have negative h bar squared over 2m times the second derivative, which we just obtained. And we can write this now as negative h bar squared over 2m times negative k squared psi equaling e psi, which is the other side of the Schrödinger equation. And this will now simplify to h bar squared k squared psi, and we have 2m in the denominator, equaling e psi. And indeed, we have shown that this solution works. Basically, a cosine kx plus b sine kx is a solution of the Schrödinger equation, because we get this function on both sides of the equation times a constant. And in this case, this constant and this constant equal each other, and we get the relation E equals h bar squared k squared over 2m, and that's the energy for a free particle.